So look at this question. This is a case study asked from linear programming. Uh, so you have the graph part of it, which is already given. So you don't have to plot the graph. And there is a story portion which is given, which you can skip while doing the exam. Let's look at the questions asked. So the dietitian wishes to minimize the cost of a diet involving two types, which is food X and food Y, which are available at the rate of 16 per kg and 20 per kg. Okay. So which are available at 16 per kg and 20 per kg respectively. The feasible region satisfying the constraints is given in figure 2. Identify and write all the constraints which determine the given feasible region in figure 2. Okay. So we have to identify and write all the constraints from the figure. So which are the constraints? So you have uh, so there are like three lines which you can identify, which is one is this, the other is this, and the other is this, correct? So we'll identify the constraints one by one. So first of all, the constraints are initially in the form of a straight line. So the first straight line is 3x plus y is equal to 8. So you would be wondering whether it is 3x plus y is less than equal to 8, or is it greater than equal to 8, because it is a constraint and it should be in the form of a linear inequality. So you'll have to take the origin test. Which of these satisfies the origin test? So can we substitute 0 comma 0 in this? So it becomes 3 times of 0 plus 0, which is less than equal to 8. So if you observe, this origin satisfies the constraint, which is 3x plus y is less than equal to 8, but the region shaded is not containing the origin. So if origin lies in this, origin satisfies this region, we have to take the region that is opposite of the region containing the origin. So which means we will consider this as the constraint. So if you observe, most of these, all of these are beyond the origin. All of these do not contain the origin. All the three constraints will not satisfy or will not contain the origin in them. So which means you can just write those constraints as one of them is 3x plus y is greater than equal to 8. The next is x plus y is greater than equal to 6. That is one of the constraints, and this is the second constraint, this is the first constraint, and so in this case, this is the first constraint I told you, and this x plus y, this constitutes the cb part, this constitutes the cb part. So this is also one of the constraints, and if you observe, ba is also a constraint. So x plus 2y is greater than equal to 10. That is also a constraint. Only three constraints are there, and you should include the non-negative constraints. X comma y is, they are both equal. They are both greater than or equal to 0. You will be given full marks only if you include all these four constraints. So identify and write all the constraints. So this is for 2 marks, right? You should not include this because this is not one of the boundaries. So what we have known from plotting the linear programming graph is that the constraint becomes the boundary of the region. Is this the boundary? This is not a boundary, correct? This is not a boundary, so it will not behave like a constraint. This will not behave like a constraint. So don't do this mistake of writing down this 4x plus 5y being greater than or less than 28. This is not a constraint at all. This is because this is not a boundary line. Okay, let's look at the second question. If the objective is to minimize the cost, so as we can see, it is an unbounded region. So what do we know about an unbounded region? It does not contain a maximum value, but it surely has a minimum value along one of its corner points. So what are the corner points? You can identify them as B. One of them is C, the other is B, and the last one is A. So there are 4 corner points. So what you can do is plot a tabular column. So let's take this point A, point point B, point C, point D. Point A is 10 comma 0. Point A is 10 comma 0, and we are supposed to minimize Z is equal to 16 plus 20y, and A is 10 comma 0. Point B is 2 comma 4. Point B is 2 comma 4. Point C is 1 comma 5. Is it 1 comma 5? Yes, 1 comma 5. And point D is 0 comma 8. 0 comma 8, and the corresponding z values are 160. The corresponding z value for B is 2 into 16, which is 32. 32 plus 80, which is 112. The third z value is 16 into 1, which is 16. 16 plus 100. 16 plus 100, which is equal to 116. 116. And the last one is 160. So if you observe the maximum, we don't want that, so we want only the minimum of these values, which is z is equal to 112, which occurs at B point, which is 2 comma 4, correct? So okay, so the values, the corresponding values, they're not just asking the z value, they're asking the corresponding x value and y value. So x should be what? 2, y should be 4. X should be 2 and y should be 4. Also find the minimum cost. This is the minimum cost. This is the minimum cost. And is there anything else asked in the question? Assuming that the minimum cost is possible for the given. It is possible. It is surely possible. It is possible at one of the corner points. So the value minimum cost is 112. Okay. So we have answered both the questions.